Hey, I hope you've done your practice, your revision. Here's a practice test, and the idea here is I'm going to scroll down and show you the 8 questions, and they're worth a total of 37 marks. And then at the end, I'm going to go back to the beginning in question 1 and work through the solutions and show you how it's done. And you can mark your work. There'll be a mark scheme there, and you can study how it all happens or how it all works. So, are you ready? The time starts from when I show you the last question, question 8, and then you can go back and gradually pause it and scroll through. Okay, so you should take about 37 to 40 minutes for this test. Let's have a look now. This is question 1, and then we're coming down. Question 2. You can go back and pause this later on and do question by question. Time yourself. Question 3. Question 4 there. Just note the marks alongside. Gives you an idea. About 1 minute per mark you should take. Question 5. Question 6. Question 7. And question 8. We'll just go down a bit. Question 8 there. Okay, so now what I'd like you to do is to rewind the presentation and move through it, because what I'm going to do now is to go on and show you the solutions. So don't keep watching. You've got to scroll back and go through those 8 questions and then go on and look at the solutions. Okay, away you go. Good luck. You've got about 40 minutes from now. Oh, here I go. I'm going to go back up screen now and put in the solutions. I hope you've had a good go at this. I hope you've been happy with each of the questions. Let's have a look now at question 1 and how you would go about doing it, finding the shaded area for 4 marks here. The first thing, of course, is to work out how you're going to do the area, and this one is probably done best by saying it's the area of the trapezium minus the area of the triangle inside. Do you remember the area of a trapezium? It's half the sum of the 2 sides, 10 plus 7, times the height, which here is 8. Minus the area of a triangle, half base times height. Okay, so there's 1 mark for that step, and then putting it on the calculator and working it out, it comes to exactly 65 square centimetres, and there's 1 mark for that. If you got the answer straight up, you can have 2 out of 2 for this. But just notice, usually we do require the steps involved in the solution, not just the answer. Let's come across to B now. We're looking at the area shaded. So can you see it's the area of the large circle there and minus the area of the smaller circle. That's called an annulus, a ring that you might put around plants or a tree or something. So that's going to be pi by what's the largest radius? Be careful, be careful. That's a diameter. So it's pi r squared minus the radius of the little one. Again, that's the diameter, so it's 2 squared. And you can do that on your calculator. And it's approximately 66.0. Of course, pi is an irrational number. We have an infinite number of decimal places, so when we round it off it is only approximate, and we use 3 significant figures. Look at the 4th figure. If it's less than 5 you keep it down, if it's more than 5 you take it up. Okay, let's mark that one now. So there's 1 mark for showing this idea of 1 circle minus another, and 1 mark for putting the numbers into the calculator. Okay, so you want a total there in that question out of 4. All right, let's go down and have a look at question 2 and see what we've got there. Okay, in question 2, here we have it, the area of the tablecloth. Now, this is a bit hard. You've got to underline some key words. Square tables of length 1.3. Let's draw a table so we get a picture of what's going on. A diagram is an important way of approaching this problem. And then they've got round tablecloths, diameter 2 metres. So they overhang. Oh yeah, I see. So it's going to be sort of overhanging. Oh, you want to put it more even than that. But you get the idea that if you put it in the centre, then the radius of that tablecloth, no, there's a diameter, what's that? See that? Diameter of 2 metres, it's got a radius of 1 metre. So it's going to overhang. The overhang is going to be even. I haven't drawn it very evenly around the outside. Our job is to find the percentage of each tablecloth that overhangs. So we want the overhang. So that's this here, the area I've just shaded. So what's that going to be? Let's work that out for a start. So the area of overhang piece will be equal to, we don't need there, overhang will equal the area of the big circle, which over the top, minus the area of the table. Let's look at that. The area of the circle is pi. Just remember, we've worked the radius out. It's 1 squared, not 2 squared there, minus the area of the table, which is 1.3 by 1.3. 1.3 squared. It's a square table, length by breadth. So we better work out that area of overhang. Well, do we need it? Let's just work it out here. It's going to be pi minus 1.3 squared. Now, don't say actually to find the area of overhang. They say, look at this word up here, the percentage of each tablecloth which overhangs its table. So, the percentage is what? Do you remember? It's overhang divided by the original. So overhang of tablecloth is how much it overhangs, percentage over the total total area of the tablecloth. And the area of the tablecloth was pi by 1 squared, or just pi. So that fraction, that's a hard thing, and then you times by 100, don't you? So that fraction of 100, because it's percent. Percent means per 100. So this is your fraction, and this is what it would be per 100, multiplying by 100. So if you put that on the calculator now, it's approximately 46.2%. And we're going to round it to 3 significant figures. Because you can't express pi exactly, it's got an infinite number of decimal places. So at the end we're going to use 3 significant figures, and we use this squiggly sign to mean approximately, or you can use this sign also means approximately. Alright, so let's mark it now. Get 1 mark, or 2 marks for this, but probably 1 for each of those. 1 mark for knowing that the overhang was 1, and then 1 mark for being able to calculate the percentage, putting the overhang over the original tablecloth area. So that's out of 4, as it says up there. So how are you going? I hope you're going all right. You might have to rewind it all and just check these solutions out, that you make sure you understand them. Let's go down to this one. Question 3 is a bit of a biggie, and it's a little bit tricky, this one. It's not quite what it seems, because you don't need to do areas straight up now. Let's have a look. A metal washer has an external diameter, here it is. It's got a width across there, if you like, of 2, and internal diameter. These are diameters of 1, so have to be careful with that later. How many washers can be cut from a sheet of steel 3 metres by 1 metre? This is a trap, because you can't just work out the area of the sheet and take away the area of, or divide by the area of the metal washers. because they have to be stamped out, pressed out of that. Okay, so you'll only get so many along here. Now, if this is 3 metres and they are each 2 centimetres long, 3 metres is 300 centimetres, 100 centimetres in a metre. So divide that by 2, they're all 2 centimetres long, you will have 50 washes, 150, washes possible along that way. What about this way? It's 1 metre wide, or 100 centimetres. And how much depth do they have here? That's still 2 centimetres. So how many would you fit along here? You'd fit 50 washes. So this is not actually an area problem yet. It's a stamping out of that shape. And you can't use the bits in the middle yet. So what's the answer to part A? We have 50 washes wide, and you have 150 long. Okay, so that is 7,500. It's going to be the product of those two, like our length times breadth, our multiple addition, 7,500 washes. That's what we're going to have there, 7,500. So that's important that you see that it is that sort of problem. It's a physical arrangement type problem, not a straight area problem. Now we're going to go into the area problem, because now it says if the metal left over, well, what would that be? See all these gaps here? When we've pressed them out, there's gaps between here. So we'll just have a lot of metal. If it was remelted and had a width of 1 metre, how many additional washes could be cut? Well, we better find out how much area remains in those pieces when we do our washes. So we better have a look at the area of a washer. Area of a washer equals pi big R squared minus pi little r squared. It's that annulus rule again. So it's pi, remember now, the diameter of the little one, of the big one, was 2, so it's got a radius of 1, and the diameter here of the little circle was 1 centimetre, so it's got a radius of 0.5. Little bit tricky here. And if you do that, you will get approximately 2.35619 square centimetres. Now we're going to keep using that number, so we need a lot of figures there. Now how many washes have we got? We had 7,500 we could stamp out of that. So the total area of all the washes was this here, 19 centimetres squared. So what does that come to? It comes to a fairly big number here. Use the calculator. Would be this. All right. So that's what effectively we've stamped out. So how much was the whole sheet? Let's have a look. The area of the whole sheet of metal, or just have a look at the area because the thicknesses are all the same, was what? 3 metres by 1 metre, but this is all in centimetres, so let's change them. 300 centimetres by 100 in centimetres squared, which is 30,000 square centimetres. So, what area remains? It's going to be 30,000 minus 17637.675. Keep a lot of figures, so we keep the accuracy and round it off at the end. So this is approximately 12362.32 centimetres squared. Do you get it? Okay, it's a fairly hard problem. That's why it's 9 marks there. Now, they say though we're making a sheet 1 metre wide. So how long will it be to have an area of this? How many centimetres would it be? Okay, so we would say, well, this is 1 metre, so this is 100 centimetres. What do you multiply 100 by to get this area? Length times breadth. Well, it will be 123.6232, won't it? Because the area in here is the length times the breadth. If you're timesing by the breadth of 1 metre, you've got to divide this total area by 100, which is therefore 123.6232. Oh, this is getting hard. Okay, so how many washers fit in 1 metre? They are 2 centimetres across, and so 1 metre will have 50 washers, width as before. And how many will fit across here? This is in centimetres, they're each 2 centimetres wide, so let's divide that by 2, and that will give you 61.8 washers worth. So in effect, what can you do? You'll only get 61, there'll be a bit on the end. So what have you got? You've stamped out in this space 50 washers wide and 61 long. So the total number of washers equals 50 by 61. 50 lots of 61, which is 3050. Total number of washers. Got a bit crowded there. All right. What did you think? Hard question. Let's go back and mark it now. Right, for this working out it was that, 1 mark. So part A, then 1 mark for 7,500. So part A is 2 marks. Then coming into part B, to find the area of the washers, it would be 1 mark for this and 1 mark for the answer. To find the total area then, what do we need? Well, we need, I suppose, this one here. So we've got 1, 2, and we've got a mark for that. 1 mark then for working out this, taking it away from the total. And then we need to work out our washers. So a sheet 1 metre wide, 50 washers by 50. What have we got? 3, 4, 5, 6. Yep, so we need to work out that distance and the fact there's 50 washers and that one. So, a bit messy, this is 9 marks. So what parts of that did you get? Notice I haven't given you a mark for the area of the sheet. Well, we've got that down here. You've got to have the area of the sheet minus the total area of the washers. A hard problem. This one's out of 9 now. I've scrunched that up a bit, didn't have much room there to do that. Do you get the idea? That is the hardest problem in this test, I think, you would have found. All right, let's go on. Coming down here now. I had a bit of room, I could have used that. Okay, there's a marquee. It's a tent, if you like. And we're going to make it of canvas to cover it over from the rain and so on. And it's cost $21 per square metre. So it's an area problem. We better find the area first and then we'll worry about the cost. So the surface area here of this 3-dimensional shape is a front and back. Front and back. And we'll do that. Plus 2 sides. Do that. Plus 2 triangular ends. And plus 2 roof sections slanting down. All of those will repeat themselves if you like. So front and back are 2 rectangles, length by breadth. Do you see that? Length by breadth. Front and the back will be the same. 2 sides, this side and the other side. And they are 2 rectangles as well, and they are length of 8 by 3. So it's 8 by 3 plus 2 triangular ends. That's a half base. And what's the base here? Well, it's the same as this, 4. Half base times r. They've been friendly. They've given us the height. plus 2 roof sections. Here it is, they're rectangles, 2.5 by 8, length by breadth. Did you get that? So you're going to give you 2 marks for all of that. You lose a mark every time you get something wrong though in that batch. And if you do that on the calculator, you get 118 square metres. So that's worth a mark. What's the cost? Don't forget. We were given $1 there, so the cost is $21.50 up here per square metre. So the cost is 118 lots of $21.50. 118 times 21.50, have to do it on the calculator, with $2,537 is the total cost. So there's 1 mark then for that, which makes a total out of 4. I think you're starting to get the hang of the idea that you should show all your working. So if you make a mistake, you can pick up part marks along the way. Okay, how are you doing there? Let's keep going. So we'll go down to question 5. Question 5 is a bit of a shorter one. So here, find the outer surface area of the filter paper. It's hollow and it doesn't have an end. Doesn't have an end there. Okay, so we'll come back and look at that in a minute. So the surface area of a cone is when you unravel it. So we unravel it and it'd be like this. A cone shape, pi rs, isn't it? Where s is the slant height and r is the radius of the original. So it's pi rs, which is pi. What's the radius? Yep, they've given us, it's not the diameter, it's radius of 2. And the slant height, they've been friendly, they've given that to us as well, 5.4. And so it equals approximately, you should put, because you're truncating the decimal for pi, 33.9 centimetres squared. Okay, and that's, we're going to use 3 significant figures. Because in IB and in SACE, they require that you give exact answers, or to 3 significant figures, or if they state something else, to whatever they state. So there's 1 mark for being able to get that, and 1 mark for the answer there. You need to have that formula sheet alongside you so that you can see the correct formula to use. Let's come on down now and look at question 6. So question 6, erecting a picket fence in a house. It's got 132, we have to come back to that. And these are the dimensions. Calculate in metre cubed. Oh, we immediately know we're looking at a volume. We're looking at a volume here. Okay, so look it up on the sheet. This body has a uniform cross-section. All along the depth there, it's all shaped the same as this here. Okay, so it's uniform cross-section. The volume of a body of uniform cross-section is the area of the cross-section times the depth or the width of the thing. Okay, thinking about slicing the body up and making the squares on the end there into cubes. So, what's that, the area of that end? Let's see if we can break it up. It's the area of the rectangle plus the area of a triangle times the depth. So I'll show a little bit of working here. Now, let's have a look at what we can do here. The area of the rectangle is all right. Here's a length by the breadth. It's 90 by 8. The area of the triangle is a half. Yes, we got it. Base is 8 centimetres. Be the same as that. Half 8. Now we have a problem. We want the height in here. That height up there. And it's not given to us. I'll just put H for the minute. Times the depth. The depth is 3 centimetres, making sure all the units are the same. Well, before we go on, we need to find this height. So let's draw that top triangle up there, out here. We are told it's got a slant height of 5 centimetres, that side there, I'm drawing it, that one really, be the same. Well, we presume it's an even picket, it looks nice and symmetrical. And then we know the base was 8, so this will come down to be 4. Okay, if this is an isosceles triangle, nice and symmetrical here, then the perpendicular from the vertex to the base bisects it, so that'll be 4. And this is our height in here. Let's use Pythagoras. The square on the hypotenuse equals the sum of the squares on the other two sides. Putting in brackets what you have done there. Therefore 25 equals 8 squared plus 16. Subtract 16 from both sides would be 9 equals 8 squared. Plus or minus 3, taking the square root of both sides. Remembering there are two numbers which when squared give 9, positive 3 and negative 3. But then we choose to say h is positive 3 because we're talking about a length, and that's got to be positive. So we give a reason for selecting that one of the two answers. So now let's go back and put it over here so we can continue our calculation. 90 by 8. Oops, nearly put a multiplication. We want to have just a plus there. Half 8 by 3. All times 3. And if you do that all on the calculator, you get 2196 centimetre cubes. This time is exactly, that's an exact whole number, no pi in there. So we now want to do 132 pickets. Oh, so let's come down a bit, need a bit of room. So total volume of all the pickets in the fence would be 132 by 2196 centimetre cubes. And if we multiply that out, we get 289872 centimetre cubes. But they want us, look back up here, they want us to do it in metre cubes. Uh-oh, how do you change centimetre cubes to metre cubes? Let's see how to minimise the amount of memory work you've got. Let's draw, not to scale of course, 1 metre by 1 metre by 1 metre. That's a metre cubed. How many centimetres? Well, each side would have 100 centimetres. 100 centimetres. This is a good way of remembering how to do units. So 1 metre cubed is 100 by 100 by 100 centimetre cubes, or a million, isn't it? 6 zeros, 10 to the 6, a million centimetre cubes, or 10 to the 6. Okay, so come back over here. To change it to metre cubes, we've got to divide by 10 to the 6. So come in 6 places. So it's going to be 0.289872 metre cubes. And generally, we would just come down here a little bit. We would say this is approximately 3 significant figures, 0.290. There's 3 figures, but this one's bigger than 5, so you take it up. It'd be taking that up causes it to get the number 90. So we've got that answer, and we write 3 significant figures. How did you go? Let's have a look at the mark scheme there. So right back at the beginning now, starting at the beginning, we would have 1 mark for getting to there, no H at that stage. Then coming over here to Pythagoras, 1 mark for setting it up, 1 mark for the answer. Then returning over the other side now, 1 mark for putting that all together. So you're up to 4 marks there. And then multiplying over here by 132, and then conversion of the units to metres cubed. You could be penalised also if you didn't round it to 3 significant figures. We might forgive that just at the moment. So there are the 6 marks. Okay, this is a bit of a trick over here, isn't it? Coming off in the middle of a problem and doing Pythagoras to find a missing height or side in a triangle. Okay, let's go on. Hope you're getting some marks there. Here's the next one. Okay, find the volume of the illustrated dumbbell. All right, well, let's have a look. It's a volume. So we need to look on the sheet for volume. What do we got? It's two discs, isn't it? This one and this one. Volume equals two discs. Well, I should put volume of the two discs plus volume of the little cylinder in the middle. Okay. How do you get the volume of a disc? Well, let's work it out over here. A disc is like a flattened cylinder, isn't it? So here, it's the area of the end. This is uniform cross-section. So it's pi r squared by however the depth or the height it is. So it's going to be pi, what's this now? That's the diameter, isn't it? Right across there, 16 centimetres. So pi 8 squared times how deep it is, it's 5. Putting it like this, it's that way. Okay. And we've got two of those. So we better put 2 times that, plus the volume of the cylinder. The skinny bit in the middle, let's put it down here. And if we did that, again it's the area of the end, pi r squared by the length, which is 13. What's r? Well, it's not 6, that's the diameter. So r here is actually 3. So the cylinder, there's only one of them, is pi by 3 squared by the length of it, 13. Okay, if you put that all on the calculator, it's approximately, we've got pi in there, so we're rounding it off, 2378.185 centimetre cubes. Okay, you could round that off now to 3 significant figures. Okay, so rounding it off to 3 significant figures would be 380 centimetre cubes. There should be cubes there. Okay, now that's the answer to part A to 3 significant figures, but we must use more figures. Don't round off too early because you will include and multiply up that inaccuracy there. So carry more figures to do part B. The mass, how much it weighs, is the number of centimetre cubes by the weight, grams here per centimetre cube. So it's 2378, just use that figure on the calculator, and it's 2.523, that would be grams. Because for every centimetre cube, that's how many grams we've got. So this is approximately 6,000.16 grams, or approximately 6 kilograms. That's a 6 kilogram dumbbell. How did you go? Well, I think here what we need to do is to have a look at, we've got a bit missing up here, it disappeared. Have a look at each part. So I think what we will have there is 2 marks for that line, and then for 1 mark for getting that answer, and then 1 mark for multiplying it up in terms of weight, and so there's the 4 marks. Okay, fair bit of work for 4 marks there, and of course that means you probably have to do it in about 4 minutes. It's about 1 minute per mark you're allowed in timing. Okay, ready for the last one? Let's come down now and have a look at the last one here. We'll just come down a bit more to there. It's a pyramid, and what we're asked for, square base, so this is all equal, watch that, the square base, and you've got a height, so find the total volume of the pyramid. Okay, the volume of a tapered solid, 1/3 the area of the base times the height of that solid. Okay, so it's 1/3 the area of the base here, it's square. So it's 230.4 by 230.4, or 230.4 squared. Easier said. And the height, yes, we've got the perpendicular height, 146.5. And this is all in metre cubes now. Metres, that's metre cubes. Alright, so we should put approximately here again, because we're going to do some rounding off. Comes to 259, 2276, reading it from the calculator, 0.48 metre cubes. Alright, we'll put the marks in as we go for this one. Only one, you're just using a basic formula, one for proper calculation on the calculator. Alright, if each cubic metre of stone weighs 2.67 tonnes, find the total mass of stone used. Okay, so let's have a look. The weight now, doing something with our volume. The weight is, we've got this many cubic metres, so we've got this many lots of 2.67 tonnes. Okay, because each cubic metre weighs 2.67 tonnes. So this is approximately 6921378.20 tonnes. And we generally round that off to three significant figures. So 692, that one's less than 5, so we'll leave it at 692. We've got to have spaces in to make sure people don't think it's just 692. So it's that many tonnes. And just come down a little bit here. And what could you do? I think probably you might say that's 6.92 million tonnes. A million is 10 to the 6. You see here 1, 2, 3, 4, 5, 6. So could you leave it in either of those forms? So there's one mark for realising you have to multiply, one mark for your answer for the total 4. Well, how did you go? What did you get out of 37? And have you learned anything? I want you to go back over the presentation, rewind it, and watch it again, see where you went wrong, and try to improve those skills ready for the proper test. Okay, good luck with that. Keep working hard. Cheers for now.